we'll be looking at the elements, little bits and pieces of the timber frame. I haven't looked at the whole thing. So we'll do that. So I'll go through this little erection sequence for the timber frame, and then I will just show you just the workings of how we take the architect's drawings, usually in digital format, how we then get it engineered, and how we get it onto a drawing board, which is in computers these days. In my drawing office, 1, 2, 3, 4, 5, 6, 7 of us, only 2 of us are trained on an actual drawing board with rotring pens and set squares and pencils. Everybody else has been right from the early days based on the computer. So let's do that then. So this is, we call this the wall plate. So there will be a foundation, there will be block work, concrete slab, beam and block, various types of underbuilding foundations. But we will put a timber plate along the perimeter of the house and any internal walls. This example is a joisted ground floor, we've seen that in a minute. We call this the wall plate. We fix a wall plate down with mechanical fixings, a Hilti fixing, or sometimes it can be shot fired. In the old days it was a 100mm masonry nail, but they don't work very well. So this is the wall plate. Some people call it a sole plate. We will then get the joist down. So we have what we call a perimeter joist around the outside, joist going across onto the dwarf walls. That's the supporting walls running through the middle. The yellow pieces are to stop the joists moving sideways when you walk over them. It's called a solid bridge or a strut, and that's what a typical ground floor joist platform looks like. Next stage, we have another timber plate, sometimes called as a panel packer or a sole plate. That's the yellow item there, and that basically helps square the frame, and that goes down before the timber frame panels comes up. Some people will put the panels straight down onto the joists, but you don't get the best of fixing doing that way if you have a good sole plate running round for your panels before the timber frame goes up. So, external panels. At Rob Roy, in our 140-38 panels, the longest panel we will manufacture in our factory is 3.6 metres. Generally 2.4, 3 metres, but we'll go to 3.6. And they're all in sections, all numbered individually, you'll see later on, and then erected round. There is no internal load-bearing walls in this house. It's just a bungalow, and you'll see the roof going on in a minute. Each of the structural timber frame panels have a lintel, usually timber, can be other materials depending on how wide the opening is, what load has got coming down on it. In Scotland, we don't tend to put, that's the next slide. This slide shows the gable panels. We call them gable panels, the angled ones. Some people call them spandrel panels. We have got 2 main gables. We've got the front gable and we've got the one over the small bay window at the front. What I was going to say was about the internal panels. These are all internal non-load bearing partitions, partitioning off bedrooms, toilets, cupboards, kitchens. In Scotland, we would tend to finish the floor first and finish the plasterboard on the ceiling and then stick the internal partitions up. Mostly down here, all the internal partitions go up at an early stage and each room gets plasterboarded out. That's quite common as well, but either or, it doesn't really matter. At some point or other, these internal panels will have to go up. Normally our internal panels will be 3 inches, the material will be 3 inches wide. Some people prefer them to be a bit chunkier, maybe a 4-inch timber, a 95mm timber, but mostly it's just a 70/45 material for the internal partition. At Rob Roy Drawing Office, we don't just detail the panels. Each technician is trained to design the roof trusses. We don't manufacture roof trusses at our premises. We purchase them from 3 3 different suppliers, but we design them. So that's the main run of trusses going up. Now, they're shown here as like an envelope. They're not solid pieces of wood, as we all know. That's just the shape of the truss. And they go from wall head here to the wall head at the back. You can notice there was the 2 small roofs at the front. These little trusses that come down off the main slope, we call them valley trusses, because they form a valley down through here, which when it's all sheeted, or just membrane as happens most of down here, that's where the water will run down through the valley and into your gutter at the bottom. Then the sub-roof here, and at the ends here, these, we call this a gable ladder, these little ladder pieces here. We manufacture them as frames in the factory. They don't come loose, so they all come individually marked, and you just put them on top of your gable panels. And a house like that, small house like that, ground floor joists, external panels, I mean, that could be wind and watertight in 2 days. You know, good weather. Of course, it never rains where we are, so it's always 2 days. So I mean, a little house like that, you know, 2-3 days, you can maybe not have it wind and watertight. Maybe you've got your membrane, might take you half a day to do your membrane on. Windows fitted. We'll term wind and watertight when the timber frame is up, all the external windows and doors are fitted, sacking is on, and the membrane is on, and then we'll call that wind and watertight. It's not waterproof, obviously, but it's just wind and watertight. And that's a step. It's quite important when people who are with us using a self-built mortgage, they will usually get a good size of payment from their mortgage company when it gets to wind and watertight stage. So it's quite a key stage in the build process. I've been very fortunate enough to build 2 houses in timber frame, and there's two main stages I get excited at. When the foundations are finished and there's no more to go in the ground, I can sleep at night, because getting the foundations done and getting your drains in and getting the slab level, that's big tick at that stage. And then the next exciting bit is when it gets to wind and watertight. You can walk through the house and then your wife starts changing things. No, sorry, they don't do that. I wasn't meant to say that. Yeah, they do, but that's what happens, you know. They're not just the wife, people start making changes when it gets wind and watertight. It's just, you walk into the space and you say, I really don't want that over there, I want that over there. And timber frame's flexible, you just need a saw and some more timber. So, and I must put my hand on my first ever house we built. We stood in the kitchen dining room, there was a window there. My wife never said anything, it was me. I said, that window should have been there. And she said, well, you designed it. Well, that's my fault then. So then we moved the window from there to there, because I had a better view. So that's a very simple house. Any questions on that at all? Any observations?
What lead-in time do you want?
Lead-in time?
Yeah.
At the moment it's between 6 and 9 weeks from the moment that we basically sign on the dotted line. So, and that's born from, because what we do is we create an order acknowledgement, which is a document, maybe a dozen pages long, which itemises everything that we are going to deliver to you at various stages. And that will go out, and that forms part of the contract. And that takes time to get that together, different window styles, colour of velux, and all sorts of things. We'll get that, we'll send that out, that gets signed in return, and then it comes to my department. I'm the technical manager at Roy Homes. Comes to my department, and I have to send out for engineering. We don't engineer in-house, we send out to consultant engineers. We use 3 different companies. They need time to do that. Then it comes back to me. Then I usually change it and send it back to the engineer and tell him to do his job right. And then I get it back again. And then it gets into the drawing office programme. We have 7 technicians. 2 are based in Falkirk, the other 5, including myself, are in Comrie. And we'll get that into that programme. And most houses will take you 2 or 3 weeks to go through the factory process. So that's not just making the panels and the gable ladders, but it's getting all the other materials in, etc. So, you know, we're getting busier from probably the 3rd quarter of last year. Things started to pick up again. It's been pretty, it's not been moving a lot in the last couple of years. It's just been very steady. So, but from October, September, October last year, things just started to pick up again. So we're seeing quite a few orders coming through now. So, but it depends on the size of the house. If you came to and said, look, I've got a small house, need it in 6 weeks, we're flexible enough to go and do that. You know.
And what about payments?
Payment, we normally ask for payment 3 weeks before delivery. That was 70% of the value, 3 weeks prior to delivery. That's standard payment terms, but the two directors will talk to clients individually about individual arrangements. We have people paying on delivery. You know, we've got, there's an escrow they call it, where the money's in an account and it's lodged there, and then both lawyers say yeah it's there, and then the timber frame's delivered, it gets released to us. So, you know, so we're quite flexible that way. We have builders who we use all the time, and they'll have a limited credit account. But most one-offs will be payment upfront or a reasonable deposit.
And what about engineering calculations?
That's all included.
The building control.
Yeah, indeed. Yeah, all that's included. We have a range of standard detail books which building control usually asks for. We also do, as we said earlier, all the SAP calculations. That's all included. Yeah. We don't do architectural drawings as such, but we do have people coming to us and say, "Can you help us with architectural drawings?" And we have a board of at least a dozen architects and architectural technicians who we put people onto, you know, various parts of the country. So, whereas we don't do it within our own drawing office, we would recommend other people to do that for you. But most people come with an architect already on board. Okay, what I'll do now, I'll just close this down. This is what we normally get from architects. We've got a CAD drawing here, floor plan, nice elevation. Reminds me of your house, Steve, but it's not. Same architect, I think, though.
Pinched it.
They pinched it, yes. They pinched your design without asking. Shocking.
Looks that way.
So we normally get given a set of architectural drawings. I will then spend several hours going through these drawings and spotting the structural issues. We will always try and work to the exact floor plan which our clients give us. Okay. So the inside face of the plasterboard, we will always try and work to that. All right. Sometimes things have to shift about, and I'm talking about millimetres here, because things just don't line up, or you know. So I'll spend a bit of time in a house this size. I mean, I think this house is about 350 square metres, or 2 stories. In fact, this is like a granny flat. Actually, this is a self-contained granny flat upstairs. And this house is all complete, finished. So I'll spend time on that. I'll send it away to one of our engineers. And what I'm asking our engineer to do is to give me the structural scheme, and I've got a PDF here of this exact house. So that went away to our engineers, and they have spent probably 3 days doing this and all the calculations needed for building control, but also what I need in terms of the technical department. So we're talking about joist spans, steelwork details, all this below here. This is all steelwork, not just timber frame designers, we're steelwork designers. All sorts of lintels, stud, wind calculations. There's a whole myriad of information that we need from our engineers, and they'll give it to us in this format. They'll basically overmark the architect's drawings, and they'll send that to us. Sometimes we'll go back and forward on a few occasions just to get a few things. I think there's a couple of revisions on this. In fact, this one was revision D. So there's always things that change during the design. So once we've got the architect's drawings, I've got my engineering. I'll task one of the design technicians to do the hard work. And this software is called Vertex. It's a finished program. I've been using it for 20 years in various versions, and this is version 17. What we will do is, if I can just zoom in, see that fireplace there? That's the architectural drawing below the CAD drawing, okay? So we've actually imported that client's architectural drawing into our software, and then we will use that to draw around to try and give you the exact footprint of your house that you want. Okay. Well, by doing that, we're not shortening your house in error or making it too big or getting the wrong span or the wrong roof pitch or whatever. We will actually use it within our CAD system, and we will draw walls, floors. And what we'll do, the very first drawing that we do is what we call our wall plate drawing. And that shows all the positions of the wall plate on top of the blockwork. If I just go into here, The technician will spend probably 2 weeks formulating and creating this 3D model. All the windows, all the internal doors, all the internal walls, the stairs being modelled. Now we're talking about 3 or 4 decimal places here in accuracy, so much more accurate than an architect needs to be. Okay, I mean, some of the architectural drawings we get are accurate to the millimetre. Some of the architectural drawings we get in are accurate to the metre. So there's a whole range that we have to deal with. And I love architects. They're my best friends. Honest. Have we got any engineers in here today? Any timber frame engineers? No? I hate timber frame engineers. So, after 2 weeks, the technician has basically got everything in there ready for framing. Now, we have to frame the walls, we have to frame the steelwork, we have to frame the roof. But before we go into that phase, we might get the clients to come in, and lots of clients come in at this stage, they sit down with the technician, and they'll walk through their house. And they'll say, look, I didn't think that was going to look like that, can I change that? Of course you can change that. This is the stage we're happy to change things. It's when it's in the factory and the chap's cutting a bit of timber that we're trying not to have any changes. But at this stage, this allows a lot of flexibility to our clients. We can do this remotely. We can send clients this software. It's not got all these menus, it's a very short version of this software, but we can give you this software. It's on there. The viewing software, that software is on the CD, and there's a few example models. You can load that on your computer in the house and you can do what I'm doing. Okay? What we do is we'll show them a little walkthrough. So that's not a door, is it? So I'll not go through the door. I'll not go through the window. Sure. In fact, I don't know where the door is. Let's just go through this window anyway. So it's not set up as an architectural tool. It's not got, all the floor finishings and coving and lights. It's not. We don't use it for architectural purposes, but there's lots of architects all over Europe and the world who use this software for architectural purposes. We're using it to get the envelope of the timber frame. Let me just jump up through here. So I'm inside one of the rooms. All the windows are modelled, and here's a stairwell. We've got some velluxes there. And this is the stair. I think I'm falling down the stairwell. Yeah, here we are. There's a stair there. So this affords clients an opportunity, time and time again, just to make some changes. And we don't mind in the slightest. Some things can't get changed without huge ramifications onto other parts of the building. So we'll take that phase, and once we're happy with the model, we'll then produce this, which is the timber frame, completed timber frame drawings. This size of house, this will have taken another 2 weeks of a technician working 8 hours a day. So you're looking at 80 hours so far to get to this. Again, we can just spin around this here. Everything you see in blue is steelwork. So all the steelwork to the gable is detailed. And we have this manufactured locally. It gets brought into our factory, and if there's any timber that needs to be shot fired, bolted to it, that all happens in our factory before it goes to site. All the dormers, they're all modelled. The resolution's not very great on this screen, but there's a little dormer there, there's a little dormer panel. We have trusses, they're all modelled as well. Timber poles. The yellow there is a sole plate that we saw earlier on. That's a sole plate there. So again, this is 3 or 4 decimal points worth of accuracy, and we have to be. And I've got some steel work around here. And once we're at that point, we'll go through a check. We'll go through an engineering check. The completed ones are always sent away to the engineer who did the appraisal. He'll give us any comments back. We'll usually send it to the architect and or the client just for any comments. And again, we can make little changes fairly easily. We call him young Graham in the drawing office. He's 30 now. He's been with us for 9 years. He had completed a house similar to this a number of years ago, and the house was angled. Came along and it was angled at 30 degrees. Had to fit this site. And it was all complete, ready to go to the factory on the Monday. And the client phoned up on the Monday morning and says it's not fitting the site. and we'll have to change the angle from 30 to 35 degrees. Now, unfortunately, it's not, I said to the guy in the first, it's not like Star Trek where you can just pick up the mouse and speak into it and it changes itself automatically. I mean, a change like that, it just basically you're almost deleting half of the building and drawing it again. So changes like that are serious, but they had to do it. Whatever reason, their site plan was wrong, and we duly obliged and redesigned it, and no extra cost to them. We just needed to get it right for them. But small changes, extending things, adding. We've done the whole thing. We've done the whole gambit of changes for people, and it's what we pride ourselves in, being flexible. And the other thing that this model gives us, when the timber frame is delivered to site, it's not just panels and roof trusses and gable ladders. It's pieces of timber, it's screws, it's metalwork, it's clips, it's all sorts of information. This model contains about 70% of all the materials that we need to put on the trucks, on the Arctic loads. This gets collected and taken out into another part of another program somewhere, and it all goes into a loading schedule, and that's what the chaps in the factory use to load the lorries. So we can get good accuracy that way. We're not, a chap doesn't sit there counting off how many pieces of this and how many pieces of that manually. If we draw it right, we load it right. And again, that's a good advantage to us. If you look at some of these layouts on plan, you can see that each of the panels are numbered, 33, 32, all the way around. They're all numbered sequentially. But each panel itself, where am I here? The screen's too small for my menus, that's what it is. Nope, I'm not going to be able to open. Nah, I'm not going to be able to open it. The screen's too small for my menus. But each of these panels, each of the panels is gets printed out on an A4 sheet. So this panel here, it's got its own A4 sheet, a little picture of the panel, sometimes you get a pack of panels that size going out to the factory, and each one gets made to the drawing. Each panel has to be checked by the other operator for squareness. We pride ourselves in making sure our panels go out straight and true in terms of the openings as well. Floor joists. Most of the time now we are using what we call an I-joist. Anybody seen that before? Yeah? Okay, so it's not a piece of solid timber, it's not a piece of solid floor joist. We actually don't use this type anymore, we use a different type. But they're incredibly strong, they come in various heights. Also, the good advantage of these is they're made in 14 metre lengths. So if you've got a building 10 metres long and with various internal walls, you can span the thing right away across it, and you're not fiddling about with short joists onto a wall head. You just put it all the way across and fix it down. So they've revolutionised floors, and they don't squeak. If you fit the chipboard properly and the plasterboard below, it doesn't squeak. Incredibly strong. So we do all those I-joist layouts. An example on the screen. And the busiest drawing, just I'm finishing shortly, is the roof layout. And again, each roof truss is individually coded. Each hanger, each piece of metal work, each clip that holds it to the wall head is all noted on the drawing. That's a truss clip. You have a bit of timber going across a wall head, you have to fix it in with a piece of metal. So if that's my truss, and that's going over my wall head, we have to have a piece of metal that holds it down. That's called a truss clip. And the last thing I want is one of my technicians counting them off. 1, 2, 3. So we put it on the drawing, and the drawing collects this for us automatically and gives us a material list. And I think just one more thing. As I said, we're not just timber framers, we're steel framers. Even though we don't particularly like steel, it's one of my pet hates, because you can't cut steel with a saw. If something goes slightly awry, or the foundations of it not level, it's just a bit more difficult to deal with. But we have good software that means we can model it accurately, and we have very few problems on site with our steelwork and then our timber frame in general. So don't want to go on any longer. That's basically how we take the drawings that you would give us, hopefully. Some of you hopefully plan to build a house. Take your drawings. We give it a really good, robust design. One thing to stress is that the British standard allows floor joists to deflect up to half an inch, 12 millimetres. They allow that. That's in the code. And lots of our competitors, they price like that. They price everything to the code so they can keep their timber frame price as cheap as possible. Well, we got out our way to make sure that we don't do that. So our floor joists are designed to deflect up to 8 millimetres. Now you think in 8, 12 it's only 4. But the difference in feel that gives to the floor is significant. So our steelwork, our lintels over our openings, our beams that go down through valleys, they're all limited to within 2/3 of the code. And we don't make any apologies for that. You know, purchasing a house, building your own house is maybe the biggest single investment anybody will ever make. So you want to do it with quality. I mean, I saw personally the house that Stephen and Amanda built at 14 Hill. We were privileged to have a tour when it was finished, and it just eat quality. You know, down to the finishings, the door handles, it was just a quality product. And that's what Rob Roy Homes are about. So that'll be the end of the presentation. If anybody has any questions, I can answer some questions now, but we'll be here, Steve, Amanda and I, till 7 o'clock, so there's plenty of opportunity for a chat individually if you require. So thanks for your patience, thanks for not falling asleep. Gentlemen. Thank you very much.
Thank you.